Hey guys, welcome back to session 20 of Java Full Stack Made Easy. So previous session we were discussing concepts related to uh, interfaces, and the last thing that we have discussed was about a marker interface that does not have any method into it. We have seen a real-time example of how do we make use of a marker interface, and as discussed in the previous session, in this session we will be talking about exception handling. So let us see what exception handling is all about and why should we handle the exceptions. Okay, so first of all, what is an exception? An exception is a runtime problem. Okay, occurs during an exception, you can say, is an abnormal situation that occurs during the program execution and terminates the flow of a program. Fine. So what is it? Exception, abnormal condition, occurs during program execution and terminates the flow of a program. So an abnormal situation occurring during the program execution and terminating the flow of a program is called as an exception. So let me just create a class for you and show you an exception demo, how exceptions work in Java and why should we handle an exception. So exceptions are abnormal situation that occurs during the program execution and terminates the flow of a program. So this part is very important. Now let me show you one simple example of an exception and see what happens. So I have just 3 lines of code. Let's call it as line 1. Similarly, I'll have system.out.println, line 2, line 3. Okay, so line 2, line 3. So what happens is if I run this, it will just print me line 1, line 2 and line 3, right? So that should be the result of this code, which is very simple. So let's run this. Looks good, no problem at all. Now what I will do is I will try to divide the number. Maybe let's say I say 10 divided by 5, right? So 10 divided by 5, this should give me 2, right? So it should give me the result of that. So line 1, 2 and line 3. Looks good, fine. But if I try to divide the same number by 0, 10 divided by 0, which is an exceptional case in mathematics. You cannot divide a number by 0. So let us see what happens if we try and divide a number by 0. So let's save it and run this piece of code and check what happens. So when I am running this particular application, it's throwing me an exception. It says Java lang arithmetic exception, divide by 0 exception. So at line 2 there is an exception, that is 10 divided by 0. But notice line 3 has no exception on it. Line 3 has no problem at all. But still line 3 is not printed here. That's what the exception says, terminates the flow of a program. So whenever you encounter an exception in your program, it terminates the flow of a program. Let me first put this into the repository for you and later we will see how can we resolve this problem. So this is our day 20. Let's create a repository for that. Day 20 demo 1 exception. So here is an exception at line 3. So this line has exception. Check the result of this line. So you need to check the result of the third line, as third line does not have any exception, but still because an exception is raised, the program is terminated and line 3 is not executed. So what is exception handling? Exception handling is all about protecting our program from being terminated. What is exception handling? Exception handling is all about what? Protecting our program from being terminated. So this is the main goal for us. We are not solving what is 10 divided by 0. We are not here to solve it. It's an exceptional case. it will occur for sure. It is going to throw us an exception, but because of the exception, our program is getting terminated. So our goal is to handle that exception. And handling an exception does not mean that we are resolving the problem. It means we are trying to protect our program from being terminated. It is not exception solving, it is exception handling. That means whenever an exception occurs, it terminates the flow of a program, and as a developer, you want your program to not be terminated abruptly, or maybe you don't want the program to terminate the flow. You want the flow to be continued, right? So because of which itself you bring in the concept called as exception handling, which protects your program from being terminated. So exception handling is a very, very easy topic, and there are these 5 keywords: catch, finally, throw, and throws. Okay, so try, catch, finally, throw, and throws. If you know these 5 keywords, you're done with the exception handling. So you know all about exception handling if you know all these 5 keywords, because it's all about dealing with these 5 keywords. So now let's learn these keywords one after another. So this program was getting terminated before. Now what I will do is I will use a try block and a catch block. Now a try block is one that protects the statement which might raise an exception. So as a developer, what you have to do is you have to surround those lines that might raise an exception inside the try block, and immediately after completion of this try block you need to have a catch block or a finally. But catch block is recommended. That's because catch is only the exception handler. So as a programmer, we know that there is a chance of an arithmetic exception being raised here, because there is a chance that the second number might be 0. So I will try and handle that exception. So arithmetic exception is going to be raised. I will handle that, and then what I will do is whenever an exception occurs, let's give some message: system.out.println divide cannot divide a number by 0. Okay, so you can do that, and also you can say which school, right? So anybody who tries to divide a number by 0, you can ask them which school do you go, right? Now let's see what happens to our program. What we have implemented is we have implemented a try block and a catch block. So let's run this piece of code and see what happens. So now you can see that there is still a problem on line 2, right? The exception is not solved. It is not giving me the result of 10 divided by 2. It's asking me cannot divide a number by 0, which school, right? So notice line 3 is executed. So which means that we have protected our program from being terminated. The program is not terminated here. The program has continued its flow. Exception is there, but we have handled the exceptions and protected the program. So this is what exception handling is all about. I hope now you have got to know about the 2 keywords, that is try block and a catch block. Try block is one that protects the statements which might raise an exception, whereas a catch block is the exception handler. So whatever exception is raised in the preceding try block, catch block can handle that exception. One rule is that immediately after completing the try block, you must have a catch block. If I include any line between the try and catch block, so that is going to give me an error. You can see that there's a try return without a catch block, catch return without a try block. So rule number 1 is that a try must be immediately followed by a catch. For compiler, it is either a catch or finally. But as a logical programmer, it is always necessary that you give a catch block so that you can handle the exception, because you are writing a try block considering that the statement might raise an exception. So when an exception is raised, you need a handler as well, right? So only catch can handle the exception. Other keywords do not handle the exceptions. Okay, that is the rule. A try block must immediately be followed by a catch block. So let me copy this and put this also into the repository. Demo 2, exception handling. So in this program also I have an exception, but my program is not getting terminated because I have implemented a try block and a catch block. So this way you can handle the exceptions in Java. So what about the other keywords? We will talk about the other keywords as well. We will go in detail about the exceptions, and also we will create a custom exception as well. So before I move on to the other keywords that are used for handling the exception, let's see what are the type of exceptions that are there in Java and what type of exceptions has to be handled, and in what situation the exceptions will be raised. Okay, so there are actually two main type of exception. One is checked exception, another one is unchecked exception. So there are two type of exceptions, the checked exception and the unchecked exception. So if you look at the hierarchy of an exception, at the topmost for Java, like for every class in Java, the parent class is object class. Object class is at the top of hierarchy of all the classes. When we talk about only the exception hierarchy, there is a class called as Throwable, which is at the top of exception hierarchy. Okay, and this is again one of the most commonly asked interview question. Which class is at the top of hierarchy of exception? So it is Throwable. From Throwable, there are two classes that are derived. Okay, so what are those two classes? Let's see that. So those two classes are error and exception. So these are the two classes which are derived from Throwable, error and exception. Under exception, there are a lot of classes, like you have seen this arithmetic exception or index out of bound exception, or maybe a null pointer exception. If you remember, we used to get a null pointer exception when we are trying to access a method on a null object, and we used to get a number format exception when we were trying to convert a string into a int. So if you remember, those were the exceptions that we have already discussed before as well. Now under this exception, there is one important class that we have to know, which is a runtime exception. Okay, the name of that class is runtime exception, and any exception class ends with exception. It is arithmetic exception, null pointer exception, IO exception, file not found exception, class not found exception, or class cast exception, number format exception. So any exception class ends with an exception. So if you see in Java, if a class is named as an exception, you know that it is an exception class. So here all the child of error, that means all error classes are checked exceptions. All exceptions are also checked exception except runtime exception, which are unchecked exception. Sorry, so this error will also be unchecked, not the checked exception. All errors are unchecked, all exceptions are checked, runtime exceptions are unchecked. Okay, so what comes under this runtime exception? Your arithmetic exception, null pointer, number format, these all come under the runtime exception itself. So what are checked exception and what are unchecked exception? So first, you just imagine this hierarchy whenever you see an exception: Throwable, error, exception. All childs of error, unchecked exception. All childs of exceptions are checked exception except runtime and its child. Okay, if a class is directly a child of exception, it is checked exception. If a class is a child of runtime exception, then that is a unchecked exception. So let's also see what these things are all about. What is this checked exception and unchecked exception? So I will put that points here. Checked exceptions. Okay, so what are these checked exception? Let's put a comment and write down all those things that we know about the checked exception. What are checked exception? These are checked by the compiler. So that means these are compile time exception itself. If you don't handle it, then the compiler is going to throw you an error. So it's a second point will be what? You must handle them, right? So you must handle them. How do you handle the exceptions? Just now in the program we have seen that how to handle the exception. We can handle it by using a try and catch block. Okay, so you must handle them using try and catch block. Okay, or what we can also do is, or we can perform a throws, or we can declare a throws to it. So if we declare throws, then what happens is we are actually telling this particular method is going to throw an exception. So whoever is calling the this particular method has to handle the exception. So throwing an exception does not mean that we are handling the exception. It means that we are only redirecting the exception. So throws meaning we are redirecting the exception to the caller. So we will understand what that caller is and how we are redirecting it in our later part. Okay, so we redirect the exceptions. That's fine now. Then first is checked exceptions are checked by the compiler. Then we checked exception must be handled. Either we can handle it by using a try and catch, or what we can do is we can declare it to be thrown. That means we are just redirecting it to the caller. So, and these type of exceptions are what usually we can recover from the situation. Usually for recoverable situation. Now, what are recoverable situations? Okay, so what are this, like what type of situations are recoverable? For an example, let's say I'm trying to write some data into a file and the file is not found, right? And I might want to print some document and my printer is on a network and I don't have a connection to the printer. So such type of situations are called as the recoverable situations. Okay, like let's give an example for you, like file not found, or maybe a network problem. So these type of exceptions are checked, must be handled. Next is unchecked exceptions. What are unchecked exceptions and what happens with the unchecked exceptions? Let's see that. Then comes the second part, that is unchecked exceptions in Java. So these type of exception are not checked by the compiler. So that means the compiler will not be throwing you an error when you write a unchecked exception. So this is one very important point to know whether the exception is checked or unchecked. If you see a line that this program must handle the exception or something, or this line throws an exception, must be caught or declared to be thrown. So in that case, you know that it is a checked exception. Whereas if you write an unchecked exception, the compiler is not going to throw you an exception, but definitely it is going to terminate the flow of a program. Okay. So this generally occurs due to the programming mistakes. That means your code has some bug in it. Occurs due to the code bug, or you can say programming mistake. So unchecked exception usually occurs in that, and it's not necessary that you have to handle it, but it is optional to handle it, unlike the checked exception. Checked exception must be handled, because if you don't handle them, then the compiler is not going to compile your code, whereas unchecked exceptions are optional to be handled, but it is recommended to be handled. Why it is recommended? Because if an exception occurs, at that time the program gets terminated. For checked exception, you have to handle it. It is mandatory for you to handle the exception. Fine. So I hope you have now got an idea about what are checked exception and what are unchecked exception. Suppose I am creating a ticket booking system, and while somebody is booking a ticket, at that time what happens is my or their network goes down, right? A network fails. So that is what? It's an external system failure. So that is a checked exception. We have to handle that. Whereas if somebody is trying to divide a number by 0, or maybe somebody is trying to access an array value which is beyond the range, so that those are all unchecked exception, because that has some coding issue in it. Our code has some bug into it, so we should fix it. It is optional for us to fix it. Okay. Now, so overall summary for this checked exception and unchecked exception is that checked exceptions are checked by the compiler. Unchecked exceptions are not checked by the compiler. handling the exception in terms of checked exception, we must handle it. In terms of unchecked exception, it is we may not handle it, it is optional, but it is recommended. So checked exceptions occurs at the compile time, whereas unchecked exception occurs at the runtime. Both will terminate the flow of your program. The cause of a checked exception can be an external problem like a file not found, or maybe a network issue, or maybe a database not found, or maybe a table not created. So those are the examples of the checked exception. This checked exception might occur in these situations, and the unchecked exception occurs due to the logical errors. That is, if your code has bug in it, at that time you might encounter a unchecked exception. So I hope this concept of checked and unchecked exception is clear to you. I'll put this into the repository so that you can read out this point, and after that we will move ahead and see the other details about the exception. So I think the core is already now cleared and covered. So demo 3, exception types, checked and unchecked exception. So the details about the checked exception and the unchecked exception is written here, so you can go through with that and understand what exactly these checked exceptions are all about and what are the unchecked exceptions all about. So let me now give you some set of rules related to exceptions. Now there might be a situation, see, whenever I was dividing this number by 0, I was not getting any compile time error. So if I am not getting any compile time error, it means that it is a unchecked exception. So there is also a possibility that I might have things like this: int x is equal to 2, 0. Okay, and I might write this line system.out.println 10 divided by x of 0. So if I say x of 0, it will be 10 divided by 2, which is going to give me the result as 5. So let's save it and run this piece of code. So I'm getting the result as 5. So if I do a 10 div x of 1, so at that time x of 1 is 0, so it is going to throw me an arithmetic exception. The program gets terminated because I did not handle it. So let's save and run it. So the program is getting terminated. It says arithmetic exception. So on this line, there is also a possibility that I might encounter a array index out of bound exception. That is also an unchecked exception because of the program bug, right? So let's run this and see that. Now you see that array index out of bound exception has occurred. So the possibility is there that on this only line, this one single line might raise a arithmetic exception, and the same line can also raise a array index out of bounds exception. So what should we do when we encounter situations like this? A line might raise more than one exception. So what we can generally do in these situations are that we can protect our statements that might raise an exception, and then we can write a catch block that handles the arithmetic exception. Okay, and also we can write another catch block that handles the array index out of bounds exception. Array index out of bounds exception, and whichever way we want to handle it, we can handle it. In general, we write e dot print stack trace, so which is again a method coming from this throwable class. As I told you, throwable is a parent for an exception. So this method print stack trace will print you what exception has occurred, on what line the exception has occurred, and what is the message of that exception. So from exceptions we can take a lot of things like system.out.println. We can even get the message from the exception. So whenever that exception was occurring, you see that there is a message given here, right? Index 3 out of bound for length 2. So if we just want this message, at that time we can write the get message, or if we want this entire details so that we can trace the exception, and then see it shows the line number on which the exception has occurred, also shows us the class and everything. So in such cases, what we can do is we can print a e dot print stack trace. The entire exception details will be shown to us, on what line the exception has occurred, what is the cause of that exception, what exception has occurred, and what is the error message. So here also I'll just add a e dot print stack trace so that I know on what line and everything has happened. E dot print stack trace. So in real time, what we generally do is we do not just print stack trace, we redirect these exception print stack trace to a file, so that we know that what exception has occurred and what line it has occurred, for what action it has occurred. So let's save all of this and let's run this now and see. So now what has happened is an array index out of bound exception has occurred. Just to differentiate between these two lines, I'll write a system.out.println. So here array problem is something I'll write here, and in the first line I'll write first line, it will give me divide by 0 only. So let's save it and run this and see the details. So you can see that line 1 is executed, there is an array problem, okay, line 3, and now your array problem has executed and printed you array index out of bound exception. So the program is not getting terminated, the program has continued its flow, okay, the flow of the program is continued, and we are getting a array index out of bound exception, and which exception has occurred on what line and all, every detail we are getting because of e.print stack trace. If we don't write this e.print stack trace, at that time only we get something like array problem. You can see that, and we might also just do a system.out.println, like we have done a get message there. We can also do a e.get message here, so which will just give us the message instead of telling us which class has encountered that problem and what is that problem. So it just says array problem index 3 out of bounds for length 2. What line and all, we don't get the details. To get those details, we can write a e.print stack trace. So the conclusion for this is that one try block can have multiple catch blocks. So there is a possibility that one single line of code or block of code might throw different exceptions. So in that case, you can go ahead and write multiple catch blocks. So generally people get confused when they are writing a common catch block. So Java supports something called as a common catch block. I'll tell you what exactly is that. Demo for multiple catch blocks. So generally what people do is, instead of writing this catch block, specific catch blocks, they write a common catch block like this. Instead of writing these two catch blocks, what they usually do is they directly write a catch block with an exception, and then they do something like this, e.print stack trace directly. So for demonstrating the things it is good, but in real time it's not good. So now it can handle both type of exceptions. You can see that line 3 is executed, it is handling an array index out of bound exception, and it can also handle a arithmetic exception. Now you'll see that it is handling a arithmetic exception, right? So it can handle the exception, any type of exception can be handled. So if I say this is null and I'm trying to take a null value, so it should be a null pointer exception, right? I'm trying to take the value from null, so null pointer exception is occurring. So this catch block is capable of handling all the exceptions. I can see that line 3 is getting executed. So the catch block is capable of handling all the exceptions, but we do not always recommend this catch block. Why is that? That is because, see, for example, if I am getting a network error, or maybe I am getting a file not found exception, so at that time I don't handle it all the situation the same way, right? So for file not found, I have certain code to be executed. For network error, I have certain code to be executed. So if an exception occurs which is outside the thinking range of us, at that time we can write this common catch block. So the best use of common catch block would be what? In our case, you add up the general specific catch blocks first. You have the catch block, write the catch block. So at the end, what you do is you provide a common catch block. So what happens in this case is that it will try to handle the arithmetic exception. It will try to handle the array index out of bound exception. So if anything goes beyond that, if suppose a null pointer occurs here, since we have not thought of a null pointer, then this particular catch block can handle the null pointer as well. So null pointer exception can also be handled, but this is how it is recommended. And also the rule says that you cannot write a common catch block first and then write the specific catch block. So if I write a common catch block above, for all these catch blocks, it says that already the exception is handled above. Why are you handling this exception? So you can see that. So unreachable code block for arithmetic exception, it is already handled by the catch block for exception, because exception is a parent, so it can handle all type of exception. Recommendation is that you have to always write the catch block, the common catch block at the end. I hope you have got the reason why should we have a common catch block. and why we should not always write a common catch block. We should always write specific catch blocks, and after that itself we have to write a common catch block. For example, if exception arithmetic occurs, I want to print hello world, and if array index occurs, I want to print array index problem, and if anything else occurs, I want to print anything else. So if I want to do that, I have to write 3 catch blocks. Else, if I just write a common catch block, all the time I am printing what? Something else. All the time I am printing something else. So we have to handle the exception as per the exception is raised. Whichever exception is raised, according to that we are going to handle the exception. That's why I always recommended to have a specific catch block first and then only a common catch block. So like a try block can have multiple catch block, one single catch block cannot have multiple try blocks. So let me write it as demo5 common catch block. So in that example itself I have shown you what is the use of a get message, what is the use of a e.print stack trace. Fine. Now let me first clean up everything that I have already written before, even the comments that we have, except the try catch, finally throw and throws, because that's something which we will be discussing. So checked exception and unchecked exception. Let's remove this. Now there is a possibility that exceptions can be nested. Now what do we mean by nesting the exceptions? So let's go ahead and understand that. So first let me clean up everything that I have written here. Once again I will write, now I am going to write 2 lines of code, system.out.println. Here I am going to write 10 divided by let's say let's write something here, 2, 0, 10 divided by x of 0, which is not going to throw us any exception. Similarly system.out.println I would say, and I'd write one more 10 divided by x of, let's say, 1. Okay, so what I'm doing is I will write a try block. Okay, and then I'll write a catch block. And here obviously I have to use a, either it can throw an arithmetic exception or it throws a array index out of bound exception. So I'll just write a e.print stack trace. It will print me arithmetic, and for array index it will print me array index. Okay, looks good. So now whenever this line throws an exception to us, that is 10 divided by 0, if this line is throwing us an exception, what happens? So this line is not throwing an exception as for now. This line is throwing an exception and it is handling that, right? So let's run it, and it is handling the arithmetic exception divided by 0, which is being raised at this line. So you can see that it is thrown on line 17, which is what is shown to us. So what will happen if the exception is at this line and this line doesn't have any exception, or maybe this line doesn't have any exception, which is system.out.println hello, okay, x of 1. So at this line only the exception has occurred. Although these 2 lines are written under a try block itself, let's see what happens to these lines of code. So when I run this piece of code, you notice that it is directly moving to the catch block, arithmetic exception. It is not printing me this 10 divided by 0 and hello. That is because whenever an exception occurs, it goes to the catch block. Your try block will not be completed. The moment it sees an exception, it switches the code directly to the catch block. So what exception is occurring here? Arithmetic, it moves to the arithmetic catch block. If there is an array index here, then it directly moves to the array index and prints you the exception as array index. So you can see that. So it will not execute these lines of code. So that's how things work in general with an exception. If you are writing a try block for multiple lines, whichever line throws an exception, from that line itself it goes to the catch block that you have written after that. Okay, so let me first copy this and show you this as well. So demo 6. These are all the set of rules that you have to remember when dealing with the exceptions. So demo 6. let's call it as multiple exceptions. So if two lines are throwing an exception, then first line itself will be uncounted, it will not go to the second line. Okay, so now what I'm going to do is I will implement things like this. There will be a try block implemented here and there will be a catch block implemented here, and I am trying to write an arithmetic exception for this. Okay, so I'm writing a nested try and catch block. So system.out.println, let's say this is nested, plus I will write e plus a space and then e dot get message, so that it shows me what exception has occurred and what is the message for that, instead of just printing a e dot print stack trace. So same thing I'll write here also, so that it will be easy for us to understand what line of code has executed. This is outer, and this will also be an outer. So now you notice what is happening is I have written a nested try and catch block. So it enters into this try block, sees that 10 divided by x of 3, x of 3 is not there. So an array index out of bound exception is occurring first. So let me first give a arithmetic exception here. So an arithmetic exception will be occurred, arithmetic exception will be handled, it goes down, and here there is no problem. 10 divided by x of 0, which is 2, it should print me 5, should print me hello, and come out of the program. So let's save it and see what happens. So I run this. So what all it is doing, it is executing line 1, line 3, that is fine. Now it comes here 10 divided by x of 1, which is 0. So 10 divided by 0 has happened. Nested catch block has handled that exception. So nested arithmetic exception. After that it comes here 10 divided by x of 0, which is 2. 10 divided by 2 is 5. Then it is printing hello, and then it goes to line 3, right? Similarly, if instead of writing this, if I write this now, which is exception arithmetic I am handling for this nested try, but here what is happening is array index is being raised. Okay, so the nested catch block does not handle the array index out of bonds. So let's see what happens if a nested try block does not handle the exception that is raised, whether the outer catch can handle it or not, and we will also see the flow of it. Let's save it and run this. So now you can see that an array index out of bound exception is handled. So that means the outer catch is capable of handling the exception. Program is not terminated. Program is not terminated. The exception is handled, but handled by the outer catch block. So because the outer catch block is handling the exception, you notice what is happening here. So 2 lines of code is skipped here. You see, it comes here, sees 10 divided by x of 3, which is array index out of bound exception, checks whether there is a array index out of bound exception here or not. So there is no array index out of bound exception here, because of which it goes out and checks, is there a array index out of bound exception here. So because array index out of bound exception was here, so outer array index out of bound exception is being created for you. It is handling it here. And that's why these 2 lines of code is not executed. So this is what happens when you have the nested try and catch block. So when you are nesting try and catch block, at that time, if the inner catch block does not handle the exception, then the outer catch block can handle that exception, but flow of the program will switch to the outer catch block. These lines of code will not be executed in that scenario. So you can test this application by uncommenting and commenting this line, and also comment this line and uncomment this line, and see the result. Okay, so this is our demo 7. Nested try and catch. So all right, we have discussed a lot of rules about the try block, catch block and all. Let's again go back to simplifying this try block and catch block, and we will also write a finally block for this. So let's remove that. System.out.println line 3. So there is a problem at this line 10 divided by 0. We know we have to surround it with a try block and a catch block. Why are we surrounding it with a try block or a catch block? Is because we don't want our program to be terminated, right? System.out.println. I want what class has raised an exception and what is the message for that exception. So get message. That's it. Let's save it. And also I'll say exception caught plus. So let's save it and run this piece of code, and in that case exception will be caught, right? 10 divided by 0 will be caught and line 3 will be executed. Program is being protected. Now there is another block called as the finally block. Okay, there is no condition again. So system.out.println, I will write finally block here. So in this case, finally block, generally the definition is that finally block is used to release the resources, gets executed irrespective whether the try executes or the catch block executes. So let's save it and run and see what happens. Let's save, run. So in this case, an exception was occurred and a finally block is executed. I will not write any exception here. Save it and run this piece of code. Again the finally block got executed. So finally gets executed irrespective of the try or catch. Finally gets executed irrespective of try or catch, used to release the resource. So what type of resource? If suppose your try block is opening a connection to the database, and if try fails and the catch gets executed, at that time what we have to do is we have to close that connection, right? And if the try block has opened a database connection and it is writing the data to the database, executed, fine. So try block got executed. After the completion of try block also we have to close the connection, right? So if the problem occurs, close the connection. If the problem does not occur, close the connection. So in such situations we will be using a finally block irrespective whether the exception occurs or does not occur. But one point that I am thinking of is finally is getting executed whether the try executes or catch executes. All looks good, definition is fine, everything is fine. But my problem is that we are handling the exception to protect the program from being terminated. That means we are continuing the flow of a program, right? So this line 3 will also be executed irrespective whether the try executes or catch executes, right? So if I don't write a finally block and write something like system.out.println without finally, even in that case it is getting executed, right? So without finally gets executed when the try block is getting executed. So let's say this is a try block, system.out.println, a try. Let's call it as a catch. So without finally is also getting executed. The try gets executed, without finally gets executed. Now catch gets executed and without finally still gets executed, right? So what is the point of writing a finally block? Why not just write it outside like this, right? So we say that finally block gets executed irrespective that the try executes or finally executes. Same thing, like we are continuing the flow of a program and anything written below that will also be continued, correct? So this is the problem of finally. You write a finally or you don't write a finally, it's still the same. So I'll add demo 7. Finally, I have shown you how finally works. Also I have shown you the problem with finally, right? Demo 8, finally and problem, right? We can write a finally block gets executed all the time, still this also gets executed all the time. So why should we write an extra keyword finally and do all that drama, right? So let us understand the actual use of finally block. See, the Java developers also, they should also be knowing, right? They also knows that the program is going to be continued. So obviously when the program is getting continued, why do you need a finally block, right? An extra keyword is created for you and then a finally block is being created. What is the reason? They're not dumb, okay? They know that. They know the flow continues. They know the code comes here and gets executed. What is the purpose of using a finally block? Let us understand that. Okay, so you remember this part, whatever I have written here. So I'll go and what I do is I'll simply say int my function. Okay, So this my function is going to divide the numbers. So whatever I have written here, I'll copy the same stuff and write it here. Okay. So when I write it here, I will say if the try block gets executed, return 0. A 0 indicates a successful return. That means a code has executed successfully. And if code contains an exception, return a negative value -1. Now the moment I write this, you notice that this line of code will be not reachable, unreachable code. That is because in a program either the try block executes or the catch block executes, right? So if try executes, it is going to return you 0. If catch executes, it's going to return you -1. So it will never come down to this particular line. So that is why it is showing us a unreachable code here. It was not showing me unreachable code here in the main method because main method was void. It was not returning anything. So since we have also discussed that methods must have a return type, because that's when the actual methods can be created, reused and everything, right? So this method is created in such a way that if it executes successfully, it returns 0, and if it is an unsuccessful execution, it returns -1. So based on the result of this method, we can get to know whether the method has thrown an exception or not. So in this situation, what if I have used a connection open or a file open and all? How will I close it in that situation? It is going to throw me this. These lines cannot be executed, unreachable code. If I write comment on that, this will be unreachable code. Now you see what happens if I write a finally block. So is it showing me an error on finally that it is unreachable code? No, it's not, right? So now even though if your method is returning some data, it is still allowing the finally to be returned. Let's mark it as static so that I can directly call it inside the main method, my function. I can now call the my function and I'll still see the result of finally block. So I'll just comment out everything, else I'll see the result twice. You can see that my function is called, save it, run it, there we go. Finally block is executed. Here catch block is getting executed and finally is getting executed. Even if a try block gets executed, still the finally gets executed. So they have created it in such a way that before returning this value 0 or before returning -1, you execute the finally and then return the values. That's what the use of a finally keyword is. Finally gets executed for sure, even if the method is returning something. Fine. So only very few people talk about this, showing you this way of using finally. Else they generally create the finally block here and then they show you that finally gets executed irrespective whether the try executes or a catch executes. But the main agenda of handling the exception itself is to continue the flow of a program. If the program continues to flow, then anything written after that definitely gets executed. But when it comes to returning a value inside a method, the flow of a program stops here or here. So that is why these lines of code will be unreachable. Even if I uncomment this and you see that it is unreachable, it is only an exceptional case for finally that it will not be an unreachable code, because finally gets executed before returning these values. Okay, I hope now the concept about the finally is clear to you. So demo 9, finally block. Fine, so let's just quickly recap the things that we have discussed about the exception. Exception is an abnormal situation that occurs during the program execution and terminates the flow of a program. There are two types of exceptions available in Java. One is checked exception, another one is unchecked exception. At the top of exception hierarchy, we have a throwable class, and two main classes are derived from it: error and exception. All child of exceptions are checked except runtime exception. All runtime exception and child of runtime exceptions are all unchecked exception. Checked exceptions are checked during the compile time, must be handled. Unchecked exception, they occur during the runtime. So it is optional to handle it, but it is recommended to handle it. Okay, and to handle the exception, we use a try block and the catch block. Try block protects the statement which might raise an exception, Cache block handles the exception. One try block can have multiple cache blocks with it, and if a nested try, that is inner try block, does not have a matching cache block, outer cache has the ability to handle the exception raised by the inner try block. And then we discussed about a finally block. Finally gets executed for sure, irrespective whether the try executes or a catch executes. So also we have discussed that to understand the entire chapter of exception handling, we should know try, catch, finally, throw and throws. So up to here we know try block, we know catch block, we know finally block. Just two keywords remain, that is throw and throws. In our next session we will be talking about the throw keyword and a throws keyword. Throw keyword is used to raise an exception, throws keyword is used to redirect the exception to the caller, and in the next session itself we will be creating a custom exception. I hope you are liking in the series, and if you like the series, you have any doubt and all, you can comment on it. If you're liking the series, then subscribe to my channel, encourage me to create more such content for you. Also share the content with your friends so that it helps me reach out to a larger audience. Obviously the end goal of this entire session for Java Full Stack Made Easy is to reach maximum people and make people productive and make somebody's life easy to get a job. Also watch my shorts for more interview questions related stuff. See you in the next video. Have a very nice day. Thank you.